Now that we have spent a few days talking about amplitude and period, it's time to talk about translations, which we can also call shift. And this is going to be a shift in the left and right direction to start out with. What's happening here? We know A and B. We've already been talking about those a lot. What's happening here is the C is what's causing the horizontal translation or shift in the sine and cosine curves. So what they're saying here seems a little confusing, but if you remember that the original sine and cosine curve started at 0, ended at 2 pi. Here's sine. Let's just use that as an example. What the C is doing is causing the cycle to now change the end point and the starting point and the end point. So what it's doing is it's adjusting that. And we'll see that in just a moment. Now, if you notice, they have taken that bx minus c and done a little bit of algebraic manipulation. And they've come up with this, which is called the phase shift. And basically what they have done is they have taken bx minus c and set it equal to 0. And then they solved for x. So they added c, and they divided by b, and they got x equals c over b. That is the phase shift, or what we call the shift in the sine and cosine curves from the left to the right and vice versa. We already know about the amplitude and the period. That's okay. That's still happening. That hasn't gone away. But what we're saying is, if this thing shifts to the left, then we could subtract off that amount from both the 0 and the 2 pi. Or if it shifts to the right, we could add on that amount to the 0 and the 2 pi and figure out exactly where they start and where they end. And that's what they're going to do here. They're going to remind you about amplitude and period. Okay, so that's not something we need to spend a lot of time on. But here, the important thing here, and this is something you're going to want to read and maybe take a note on, the left and right endpoints of one cycle interval can be determined by solving the equation, not just bx minus c equals 0, but also bx minus c equals 2 pi. So basically what they're saying is if you take that stuff in the parentheses, whatever that is, and set it equal to 0, and take that stuff that's in the parentheses and set that equal to 2 pi, you're going to get the x-coordinate, okay, just the x-coordinate of your new starting point and ending point with the translation. So let's see, negative 3 cos 2 pi x plus 4 pi. Negative 3 cos 2 pi x plus 4 pi. So if I put everywhere I see x, which is just here, a negative 2, I'll get negative 3 cosine of 2 pi times negative 2 plus 4 pi. Now this negative 2 times this negative 2 is negative 4 pi plus positive 4 pi. Well, we know what that's going to be. That's going to turn out to be 0. So cosine of 0, if you go back to the unit circle, cosine of 0 is 1. And 1 times negative 3 is going to be negative 3. And that's where that came from. They're taking those endpoints and they're substituting them back into the original equation. And yes, it involves a little bit of work on the unit circle. So that's helpful to see how that applies to what we're doing now, that can be very useful for us. Hopefully that helps give you an idea how they got those points. And now they're going to take those points. Here's the -2, -3. Here is, let's see, that's 1. This will be -1 right here. Just going to label that. And you'll see the 4 points. You'll see the -1.75, the -1.5, and the -1.25. And you'll see how that graph got divided into its 4 pieces. Now, as far as this vertical translation goes, these are a whole lot more straightforward. Out here on the right, you can see, let me highlight that a little bit. I wanted to highlight that, not scribble. Just 1 second while I grab a highlighter. There we go. This amount here, this D, this is what's reflecting, I'm sorry, not reflecting, this is what's representing the vertical translation, the up and down shift. And that shouldn't come as a surprise to us. That's normal for most functions that we've studied in the past. When lines are shifted up or down, their y-intercept is what's causing that to happen. So what it's saying here, and this part's particularly helpful, I think. I'm going to highlight this part right there. The shift is d units up for d greater than 0, and d units down for d less than 0. And so what's happening now, the graph is now shifted in a direction, up or down, and the middle of the graph is no longer the x-axis. It's the line y equals d. And we'll look at that a little bit as we go through this over the next few classes. That horizontal line is going to be sort of what we call a midline. And let me grab a pen to write that down. In the past, as we've been graphing sine and cosine, the x-axis has sort of been that grounding middle area, but this middle area now is going to shift, and that's called the midline. And I think you can envision why that would happen, because this graph is being shifted up and down. It's going to change in a vertical way.